Alright, so let's go on learning the networking operation in Ruff application development. In our previous lessons, we talked about the characteristics and usage of TCP protocol. In this lesson, let's talk about HTTP. HTTP is a higher layer communication protocol, a communication protocol at the application layer. It realizes encapsulation of TCP protocol. There are also two roles in the scenarios of HTTP protocol. One is server, and the other one is client, which is the same as those in TCP. Server is the service provider, and client is the service user. The figure below well illustrates the scenario. Often, it is upon the establishment of HTTP server that HTTP client launches connection and uses URL to launch connection. After it successfully gets response, the HTTP server sends back a content. An entire connection ends here. And both communication parties do not maintain this connection. Our Ruff also provides the HTTP module, and it mainly provides some encapsulation of HTTP protocol, including server and client. Both Node and Ruff provides HTTP modules, and both are the same. Like the net module, it is compatible. So, for information on API, we may also go to the homepage of Node.js to find the entrance to the document. The way of reference is also similar. Use require HTTP to get this module. And this figure explains in a more detailed way how to achieve this effect. Let's have a look. In fact, HTTP client sends a request to server. And this request includes the basic IP address and the port number, as well as path. For example, the access path and mode of access, which will be talked about later. There are actually two modes, get and post. After it sends request, the server will return to the client a response. And this response contains the response code and some other content inside. Next, a very simple example of code. In fact, here we use the HTTP module to achieve a basic effect of access response. Let's first look at the server. As for the server, after it gets the HTTP module, it establishes a server and then monitors the port number 8888. After the client connects it, it will enter this callback function. This callback function has two parameters, including request and response. At the very beginning of this callback function, we rely on the URL to parse this request, and then get the path, which the client will access. Then we'll judge whether this path equals test. If they are equal, we will return to client a response code 200 and some other contents, and we also return to it a message. Okay, let's look at the client. As we see, the client code is also very simple. It mainly means the HTTP originating a request, followed by an option. And this option has three parts. The first one is the IP address. The second is the port number. And the third is the access path. After it has made successful access, it waits for a message right here. And if it receives a message from the server, I'll directly print this message. Let me demonstrate it right here. First, execute server, then client. As we see, the client receives a message. Okay, that's one of the most basic usages. As we said before, there are indeed two request modes for client, namely get and post. As to the characteristics and usage of both request modes, we may look at the table below. As for the request mode of get, if we want to send some request contents, such request contents must be put in the path, and its advantages its simplicity, and its debugging is also convenient. Its disadvantages is poor security, since it directly puts the request contents into path. In post, some improvements have been made over that. It sends the request contents through the new request object, instead of directly writing plain text in the path. So its security is higher. First, let's look at the request mode of get. Open this client get. Let's look at the client first. Compared with the simplest case before, in fact, this option has a method. I specify that I make the request through the mode of get, so path has a content. For example, based on the original one, I add a question mark to test, and then put content into it. This content actually uses the QS module to realize a string to it, and then put it here. Then originate this request. As for the server, it first judges whether the method equals get. If yes, it parses the path after parsing using URL to parse the detailed request contents to be accessed. As we see, the final parsing result is an object, and we may print this object here. After we print it, we return a string OK to the client. Let's demonstrate it. After server executes, let's execute client. In fact, what we get from server, the parsing result is an object. It's actually ID, and then 001. As we see, client actually sends such an object. Next, let's have a look at the request mode of post in an instance of its usage. We open the code of post server to open client. It is different from the previous get mode. Its method, we actually use post, and the path here is not followed by the request contents. As we see, as for the request contents, it is through the newly created request object and its write method. Then we send out the content. Let's look at server. Server is the same. That's to say, when it determines that path name is correct, the request will then wait here for the message. After it gets the waited message, it will parse it through the QS module, and then acquire such an object. Let's demonstrate it. As we see, it has been printed here. The object that client wants to send is an ID, and its value is 001. Alright, so that's all for this lesson. So please look forward to our upcoming classes on Ruff. Thank you very much.
Ruff, make IoT easier.